everybody. The last video only went through, I think, problem 37. So I'm going to pick up with 41 and try to give you the rest of these examples. We got a lot of people out sick right now, so they're going to need a little bit of extra because they're not able to be in class. So 41 says that a daycare center has 30 feet of dividers, with which to enclose a rectangular play space in a corner of a large room. The sides against the wall require no partition. Suppose the play space is X feet long. Okay, basically I've got a room and I'm going to want to enclose a corner of the room, but I only have to do this side and this side because the walls are going to make the other two sides. And I've got 30 feet to work with. So part A says express the area as a function of X. So if I make this side X and I have 30 feet to work with, remember on the others we had to take half because we were going all the way around the rectangle. Well, now we're only going halfway around. So if this side is X, then this side over here is 30 minus X. So the area is the length times the width. Or we can write it, if I distribute, that'd be 30x minus x squared. Part B says find the domain of the function. They already have it graphed, so if you look at that graph, it goes something like this. It goes like 0, 30. It has a high point at 15 to 25. The domain for part B is x can be anything between 0 and 30. Now it would look for a really, really weird area if this side were only 1 and the other side was 29, but it could work. It'd just be a really long skinny play area with your kids all lined up. Obviously that's not going to be the best possibility, but it would be a possibility. And then part C, they want you to use this graph over here to determine the dimension that yield the maximum area. So when X, it looks like this high point here, they've already found, is at 15 to 25. So when X is 15, so the dimensions of the room would be 15 feet, that's X, and then this side 30 minus 15, which would be another 15 feet, yield an area of 225 square feet, and that's the maximum area that we could get. Typically, if you're looking at rectangles, the biggest area is going to come from a square. That's how we do 41. 42, we've got a corral, and here's what's going on here. We have got 360 yards of fencing. They tell us that this side over here is X. There's water over here, so we're not going to fence over here. So they want me to find the area of the whole corral. It's split up, but they want me to find the total area. If this side is X, then so will this side and this side, just because it'd be the same length. That means that this long side here would have to be 360, that's my total, minus X and X and X, or minus 3X. So the area here is going to be part A. The area will be X, the length, times the width, which is 360 minus 3X. Part B, they want to know the domain, and they have it drawn again in part C. They want you to use the graph in part C, and that's going to help. In part, the graph shows that this maximum point is at 60, 10,800. If you look down here on the bottom, it goes from 0 to 120. So the domain here, in order to get a positive area, if you're looking at this graph, it's going to go, the domain is going to be between 0 and 120 yards. You can't have an X value that's more than 120, because if each of these were 120, it would add up to 360, and that's all you have. It'd leave you nothing for this side. But if they were just under 120, you'd have something for the top. Obviously, you don't want them to be you don't want them to be 119, 119, 119, and only have, 3 feet for the top, but it would be a possibility. And then part C, using the graph below, which is this graph, they want to know what is the dimensions that yield the maximum area. So it's when x is 60, you get the most area, which is 10,800 square yards. So if x is 60, the dimensions of this cattle corral would be 60 yards by this side. If x is 60, this is 360 minus 3 times 60. That would be 180 yards. That yields the maximum area. All right, and then 43. In 43, you've got this box, and so we've got something like this, and they want to cut out the corners and fold it up. And when they do that, this was 12. But when you cut it off, this is x. So no longer is this length 12, it's only from here to here, which is 12 minus 2x. And from here to here is 12 minus 2x, and the height would be x. So the volume is going to be 12 minus 2x times 12 minus 2x times x. See, I'm taking x off both sides, so if it was 12, that'd be 12 minus 2x. So that's part A. Part B wants to know, what can the domain be? What can x be between? Well, x can be between 0 and 6. I can't take more than 6. I can't take 6 off of each side if I only have 12 to work with. And then part C, graph the function with a graphing calculator. So I'm going to go to my calculator, and I'm going to type this in. 12 minus 2x times 12 minus 2x times x. And 12 minus, whoops, I need to put parentheses around that probably. 12 minus 2x, that's the length, times 12 minus 2x, that's the width, times x. And for my window, I'm going to go from 0 to 6 on the x. Let's see, if I had 6, let's see, let's go up to about 200 on the y max. Let's see what that does. It might be too big. All right, whoops, not the table. I'm going to graph it. All right, so there we get a graph, and they want me to, so graph it with a graphing calculator. So part C I did, and they didn't ask me to do anything but graph it on a calculator. So I did that. And part D says what dimensions yield the maximum volume. So I'm going to find the max. Second, trace 4. I need a left bound, so go to the left of that top point, which will be somewhere over here. Push enter. You'll notice it draws a vertical line. It says right bound, so go to the right of that top point and push enter. And then it says guess, push enter one more time, and I get, see it says 1.99993, that's really 2. So when x is 2, I get a maximum volume of 128. So they want the dimensions. So when x is 2, this side here would be 8, and this side would be 8, and the height, which is x, is 2. Plug it in 2, this side would be 8, this side would be 8, and this side would be 2. So that's the dimensions that give you the maximum volume. And then finally, problem 47. Oh, that's a 47 is a piecewise function. It's not a word problem, but I'll go ahead and do it. They give you just 2 different equations. You're going to use x plus 4 if the x value that you're plugging in is less than or equal to 1. And you're going to use 8 minus x if the x value you're plugging in is greater than 1. They want you to plug g of negative 4, and they want you to do g of 0, g of 1, and g of 3. All right, g of negative 4, that what's in here is your x. You see that? So that x value is less than or equal to 1, so I'm going to plug it in here. So I'm going to do negative 4 plus 4. I don't use 8 minus x because my x is not greater than 1. I only use 8 minus x if my x is greater than 1. All right, g of 0. Again, I'm less than 1. 0 is less than 1. So 0 plus 4. I'm going to plug it in here. 0 plus 4, my answer is 4. G of 1. I'm still going to use the top one because it says x is less than or equal to 1, and this is equal to 1. So 1 plus 4 is 5. And then g of 3, since 3 is bigger than 1, I'm going to use this one. 8 minus 3, my answer would be 5. And that's how you do those. All right, I'm going to get this uploaded, and hopefully you'll have 2.1 done.